Okay, let's go over some examples. We're going to keep the information about solving a second order differential equation with constant coefficients here. So this is our case one, where the coefficients are constant. Like this case, a y double prime plus by prime plus cy equal to 0. So we have a m squared plus bm plus c equal to 0. This is the first one. If m1 and m2 are real solutions, y becomes c1 e2 m1x plus c2 e2 m2x. And if it's real solution, real repeated solution, so it's a real m1 is equal to m2, real solutions, y becomes c1 e2 m1x plus c2 times x e2 m1x. And finally, if you have imaginary numbers, m1 is alpha plus bi and m2 is alpha minus bi, then y becomes e2 alpha x, parentheses, sine, cosine, it doesn't matter which one you write first, c1 cosine beta x plus c2 sine beta x. Very good. Let's go over a couple of examples. This example says solve the following differential equation. Here you have 2y prime, y double prime, minus 5y prime, minus 3y equal to 0. Very good. So let us construct the auxiliary equation. This is just a second order homogeneous differential equation of order 2 and with constant coefficients. This is a second order differential equation with constant coefficients. So this is our first case in solving a homogeneous second order differential equation. We need to construct the auxiliary equation. Auxiliary equation becomes becomes 2m squared minus 5m minus 3 equal to 0. Well, we can solve this quadratic equation. M is equal to negative b, 5 plus minus square root of b squared minus 4ac 24 divided by 2a or 4. So m becomes 5 plus minus square root of 49, 7 divided by 4. So m1 is equal to 3 and m2 is equal to negative a half. Very good. This is the case that these solutions are real solutions. So the general solution for this differential equation becomes c1 e2 3x plus c2 e2 negative x over 2. The second equation, example, question says solve the following. Here we have the second derivative of y minus 10y prime plus 25y equal to 0. Well, again, this is the case that we have a second order differential equation with constant coefficients. So the auxiliary equation becomes m squared minus 10m plus 25 equal to 0. So this is the case that we have m minus 5 squared equal to 0. m is 2, m is 5 with multiplicity 2. So it's repeated twice. So this case, y becomes C1 e2 5x plus c2x e2 5x. This is the general solution that we have. And finally, the last example is the second derivative of y plus 4y prime plus 7y is 0. The same process. You get m squared plus 4m plus 7 equal to 0. So m is equal to, well, negative b plus minus square root of b squared minus 4ac 28 divided by 2. So your m becomes negative 4 plus minus. Here you have negative 12 divided by 2. So your m becomes negative 4 plus minus. Here we have 2i square root of 3 divided by 2. So m1 is equal to negative 2 plus I times square root of 3 alpha plus I beta, and m2 becomes negative 2 minus I square root of 3 or alpha minus I beta. Here you have the conjugate of these two complex numbers. So this is our last case. In this case, y, the general solution, becomes e2 alpha negative 2x parentheses c1 cosine of beta. Beta is square root of 3x plus c2 sine of square root of 3x.